Hi, we're here with the battery group from Foxconn. I've got Sam, Angus, and Dr. Sally, and they're going to walk us through the battery solutions that we offer. Sam, take it away.
Hi, I'm Sam.
So tell us what we have here and the different batteries that we're looking at and what they're used for.
Okay, so here is our EV battery, and Angus will charge this battery, and we also have lithium metal solid state battery, and this is very high energy density, almost 420 watt-hour per kilogram, and this is for drone.
Okay.
Yeah.
So they're very lightweight.
Yeah, very light and very powerful. Yeah.
Okay.
So Dr. Sedin will charge this battery.
Okay.
Yeah.
Very nice. So what's the technology here? I mean, is this lithium ion? Is this a different chemical? How do they work?
How they work? So Dr. Sedin, will you show your material design here?
So this is your design.
Yes.
Very nice.
We show the two type of cell,
Mhm.
and one is the power type, another one is the energy type.
Okay.
Yes. The energy type has a high energy density, over 320 watts hour per kilogram. So
That's
yes,
a lot for.
So it can let the drones fly longer.
Okay.
Yes, another one, our type is we add the nano material to enhance the high current discharge. So it can support the 50C post discharge performance.
Mhm.
Yes, and so both cells are test the hot box test and the high altitude test.
Okay.
It can show their stability and safety.
Okay. So they work in the altitude where it's colder,
Yes.
the temperature fluctuation.
Yes.
Okay. Now, for folks who don't understand the amp hours, the watt hours, how does this compare to like the 12-volt battery that's in somebody's car? So we have Anne here from the battery group who's also going to help us explain a few things.
So your question is asking how they are different from the
How that
EV
compares to like a car battery, because people will understand a car battery, but they might not understand, this.
Well, for EV battery, of course, we are looking for long range and more safety. That's
Right.
Of course. Yeah, but however, for drone, this kind of application, normally we will look for only 300 to 500 cycles. Because some of the mission that they need to perform, maybe it's just one way or
Okay, right.
more limited of time.
Mhm.
So that's different from EV. But based on that, because chemistry is overall a very balanced solution. So in order to enhance our features, like very high CD discharge, very high power discharge, then we will put more focus on that.
Okay.
On the other hand, the lifespan will be shortened. So I would say that will be the main comparison.
And that's very good. That makes sense then, because it doesn't have to last as long.
Right.
So you can make it smaller and more powerful.
Yeah, because for EV drivers, they often have this anxiety
Well,
about range.
yeah.
Yeah. And always look for where's the
I,
next stop
I
to
worry
charge.
I worry about my phone. I'm like, I don't have battery. I don't have battery.
I know. But for like drone, I mean,
Right.
there are different kind of drone. This kind of battery is probably more suitable for like agriculture use because the UC is
Okay.
larger.
Mhm.
But there are also we can apply this kind of chemistry. This is using the anode material like lithium metal.
Okay.
Yeah, lithium metal, which is a very powerful anode material, which is different from like silicon carbon that we normally see
Okay.
in the EV battery. Yeah. So with this lithium metal chemistry, and we can actually make the smaller smaller battery, smaller size, and on other maybe more like FPV.
Okay.
Yeah, you know FPV, right?
Right.
Okay.
Right.
Yeah.
hmm
So,
Okay, good. That makes sense. So it seems like the technology is
Right.
advancing quite a
Right.
lot.
Yes.
I honestly hadn't considered the fact that life cycle and use cycle
Yeah.
would be less in different applications.
Yeah.
So that would make sense to that. So
Yeah,
that's great.
because, yeah, especially for you will not drive a car under like minus 40 degrees, right?
Well, hopefully not, but
Yeah, but for
it gets
for-
cold in Northeast Ohio.
Yeah, but for drone, yeah, there's a
Right,
chance
'cause-
that it has to be performed
Right.
under that strict, very difficult
When
situation.
you're at altitude, it's
Right.
minus 40, minus 50.
Right.
Okay, that makes yeah, because that was the question I had asked was the
Okay.
temperature sensitivity.
Yeah.
So that's that's good.
Sure.
Thank you for talking with us today, and we're glad to be working with you.
Sure.
Thank you.
Yeah, my pleasure.
Thank you.